I'd like to show you the setup for synchronizing one or more AWGs. And this setup we have here is using, this particular setup has two channel AWGs, and we're going to be synchronizing these two boxes, and we'll be looking at the trigger jitter on the oscilloscope. And so I'll take you through step-by-step process of how to calibrate your AWG so that you stay synchronized when you change waveforms or start the acquisition again. So start with I also wanted to show you the back panel of an AWG so you have an idea where the signals will be coming from. So the configuration that we have, like I said, the two AWGs. We have an AFG up here that will be used as our reference clock and also as our trigger that we'll be putting into the input. So on the back of the AWG you have reference in, and you can see that this will allow from 35 to 250 megahertz reference. So we're going to be using that as our reference input that is coming from this AFG up here. And right now we have the reference input set for 128.8 megahertz. And you can see that that's a sine wave that we're using for this particular clock signal. Now on the AWG we can also multiply this value so we can get up to the sample rate required. Like I said, we use the reference in. We use, in some cases we may want to use the clock out as a trigger or a clock for the sampling scope. So we're also using the clock out in this case. Other than that, the trigger in will be used by these two SMA, or actually we'll just use one SMA here for our trigger, and the trigger will be coming from this channel of the AFG. And if we look at that channel, we can see that it's just a pulse, and we'll use that as our trigger in order to guarantee that we're getting the trigger in synchronization with the reference clock. First of all, to set this up, we're going to start with the AFG. The AFG again is being used as our clock reference and also as our trigger source. So as we can see here, we're looking at our clock, and we've set it to 121.88 megahertz for our clock, and that's something that was requested by a customer. And for our trigger, we've basically set it up in correlation so that the trigger will be synchronous with the clock, and we'll use this as our trigger input for this particular test. So the idea is that with each trigger, the two AWGs will be synchronized with the output of whatever output you would like to use for your testing. So now I'm going to move over and show you some of the menus on the AWG. So first of all, we're going to go to our home setup here, and for the adjustment calibration we're going to just use a 4,800 length pulse basically. And you can see that we're also showing the markers here that we use for our sampling scope. And so we have both channels set up with the same signal. And in this case, we can provide this skew adjustment signal. It's a fairly basic pattern. And so we have loaded that waveform into both channel 1 and channel 2. So now as we go, and we've also set up our trigger input for the A trigger, and we've set up our run for triggered continuous. So the idea is that it will not start until we get a trigger. So right now I'm going to go ahead and turn off my trigger on the AFG until we're ready for that. And also I'm going to turn off my channel, or my AWG outputs, so we don't have an AWG output either. So in the next menu is our setup menu, and this basically allows you to turn on channel 1 and also set your amplitude. We really won't have to do anything in this particular menu. So now we're going to go over to under our clock setup. We will go ahead and show you what the clock setup is configured for. So we're using our reference in external variable, and again that comes from the AFG, and the AWG provides you the capability of detecting the actual frequency. So we can go ahead and detect that, and indeed we're seeing the 128.88 megahertz as our clock frequency, and it did come back. We also turn on jitter reduction, and this just removes the chance that we're going to get a little bit more jitter. Now we use the multiplier to actually multiply up to the sample rate required. So in this case the sample rate is 24.38 gigasamples per second. Now we can also turn on the clock output, and we use this as our basically our clock for our sampling scope, so that we can synchronize our sampling scope with the AWGs. So that's basically the configuration in the clock setup. And now if we move over to trigger, basically we just need to set our trigger level. We have already set it for a trigger source, and we'll just leave the rest as default. We also want to make sure that we're in slow sync mode, and this allows us to have a wider window for our trigger, so that we don't run into trigger uncertainty issues. So it's very important that you use this slow sync mode whenever we're doing synchronization. When we're not synchronizing, then we recommend using the fast or async mode. So that's really basically the configuration to start the calibration. There really is nothing under the File Utilities menu. So at this point I'm going to set up the AWGs and get a trigger, and then we can start calibrating. And the calibration itself is under setup and under channels, and you can see this output adjustment on the bottom here, and we're going to output adjust all of the signal inputs. And right now it's been pre-configured so that we've changed the skew. I'm going to go ahead and change this back to 0 so that we're starting from scratch, and you can get a better idea of what we're trying to do here. So the idea is to put the AWGs into a ready state. So if we push the play button on the AWGs, they will be waiting for a trigger. So both AWGs are set up identically. There's no difference between the two at this point. So now both AWGs are waiting for a trigger, and you can see that the icon up here shows you that it's waiting for a trigger. Once it's running, that icon will show you that it's running. So now what I'm going to do is go ahead and send a trigger to the two AWGs with the AFG. And you can see that now we've triggered, and we are outputting on both AWGs. So I'm going to go ahead and start the calibration here in just a second. Okay, start off with we're going to go ahead and arm the AWGs. So we've armed both AWGs. Now we're going to go ahead and send a trigger from the AFG. And you can see that the gap between the two channels, so what we're looking at is channel 1 of the top AWG going to channel 4, which is the green trace, and then we have also channel 1 from the second AWG, and it's going to the yellow trace, or channel 1. Now what we're seeing here is we're triggering off of channel 1, and if we position this, we can see that the AWGs did not align very closely on the outputs. So this is the time-consuming part, in the sense that we need to repeat it again and see if we can get this these two edges very close, within 2 nanoseconds. So I'm going to go ahead and unarm the AWGs, turn off the clock, rearm the AWGs, and okay, now we're going to go ahead and adjust the phase on the AWGs in order to match the output channels on both AWGs. So you can see in this case where the delta between the two AWGs is 3.9 nanoseconds. Now I mentioned earlier that you should really try for 2 nanoseconds, but if you use the phase control on both AWGs, you can actually go up to 4 nanoseconds. So I'm going to go ahead and leave it at 3.9 nanoseconds here and see if we can adjust it in. So the idea is to adjust the phase until we get these two channels lined up. So I'm going to go ahead and put in a fairly large number here. So I'm going to go in and put 10,000. And you can see that they move closer in this case. Now the maximum amount that we have available on our phase adjust is 10,800. So there's no way I can get lined up with just using one of the phase controls for the AWG. So I'm going to go ahead and adjust in the other AWG now, and you should see it change. So I'm going to go ahead and adjust it. I may have to adjust it in the negative direction. Let's see here. So I'm going to go 5,000 on the other AWG. And we are getting closer. So that was actually minus 5,000. So let's go up to minus 5,500. And so we're close enough now. We should be able to zoom in on it a little bit more so we can get a little bit more detail. So I'm using the adjustment here. That's going to take forever. So let's go up to minus 6,000 degrees. Not enough. Try minus 8,000. So this is kind of a hit and miss operation. Oops. Enter the number. So we're getting closer. I went the wrong way. So let's go minus 7,500. Now we should be able to adjust it in with the dial. So now I'm just dialing it in as close as I can get. And the idea is, once you get it dialed in, then you shouldn't have to mess with this again, as long as you don't start the clock over again. So the idea is to make sure the clock is always running. So right now we're showing you the calibration waveform on both AWGs. So the next step would be to load in your particular waveform and make sure that it's synchronized.